So let's take a look now at how we might actually be able to use the intermediate value theorem to help us answer some different questions. Take a look here at example number 1. This is actually a question that is extremely similar to, in the same spirit of, a question we talked about at the very start of 2.2. Suppose that Bob and Alice each take a 9-hour trip during the same time interval. Let's pretend it's like from noon to 9 p.m. And the temperature that Bob is experiencing at any given point in time during his trip is given by a continuous function b of t. So it's Bob's temperature. Similarly, the temperature for Alice is given by a continuous function a of t, so Alice's temperature. Both functions are continuous on this interval, say 0 to 9. Suppose that we are told the following. At time 0, Bob's temperature is negative 15, say, degrees Fahrenheit, and at time 9, Alice's temperature is negative 15 degrees. Remember, this was a scenario where we had Alice and Bob kind of being on different starting points, and they were kind of making trips to each other's destination. Right? So they're swapping. So after the 9 hours, Alice is where Bob was at the beginning. So Bob's start location is Alice's end location, and vice versa. Now it seems like here, Bob is going to maybe be starting at, say, the North Pole, and Alice is on the equator where it's very, very hot. And our goal here is to prove that there is some time where the temperature that Bob experiences is equal to the temperature that Alice experiences. Now our goal to do this is going to ultimately be to try to use intermediate value theorem. And intermediate value theorem, you'll note, works with a specific function and tries to figure out if that function will ever hit a value. Okay, take a look at how I'm going to start here. If we want b of t to be equal to a of t at some time t, then we want b of t minus a of t to be equal to 0 at some time t. Doesn't that seem to make sense, right? If I want these two things to be equal at some point, then that means that I want their subtraction to be 0 at some point. Now, I don't know if their subtractions will ever equal 0, but let's see what we have. I'm going to go ahead and state, how about I create a function that calculates for me the differences between their two temperatures. I don't know what those differences are going to be, but let's suppose that that's what f tells me. F tells me the difference between the two temperatures. Now, automatically, since a is continuous and b is continuous, I know that f is continuous. So I'll say since a of t and b of t are continuous on the interval 0 to 9, then f of t is continuous on the interval from 0 to 9. It's got to be. That's one of the ideas we talked about in the last section. But I can now start to think about a picture of what f is going to look like. So if I want now the f function that I'm talking about, at some point I'm hoping it will hit 0. So 0 is kind of the value that I want to hit. And so what I need to try to establish is a value of my function that is going to be above 0 and below 0, and then, since it's continuous, I know it would have to cross 0 somewhere. So let's take a look at the only information that we know. Let's see what we have. I could say we know that f of 0 is equal to b of 0 minus a of 0. Well, let's see. b of 0 is negative 15, and a of 0 is going to be 100. So that gives me negative 115. So that's kind of like a lower point in my picture. I also know that at 9, I get b of 9 minus a of 9. And that is going to be 100 minus negative 15. That's 115. So I can easily go ahead and see here that I'm going to get a point that's above. You can almost kind of imagine that I could redraw this picture slightly, right? I have a point at 0, negative 115, and then at 9, positive 115. And since my function f is continuous, I know it has to cross somewhere, some value of c. So here's how I can write my conclusion. By the intermediate value theorem, or what we'll commonly abbreviate as IVT, there is a value c. Notice it's in the interval from 0 to 9, that's where it's between, such that f of c equals 0. But of course, if f of c is equal to 0, this means that b of c minus a of c spat out 0. That's what it means for this to turn into 0. And of course, that means that b of c is equal to a of c, which is exactly what we were hoping to show. So this is a really, really cool argument, right? It's a little bit complicated, but it's really cool. And we'll see again that we can understand slowly how this intermediate value theorem works. We had a function. We wanted it to hit a particular value. So we found a point below and a point above. We confirmed it was continuous, and we were able to get what we needed. And we'll see more of how to do this in the next couple videos.